Here we have a sidewalk on a street on a nice cloudy day. There are a couple of different types of brick used in the walk, but they don't look too much different to our eyes. Now let's see what an infrared camera would show us. Since the entire sidewalk is at the same temperature, why do we see this great difference? Welcome to Emissivity Explained in plain English. In the visible world, we see objects by reflected light. In the infrared world, everything glows with its own infrared light based on its particular temperature. Hot items glow brighter, and colder surfaces are dimmer. As we can see here, an insulation void in the wall is making a stud section cooler than the surrounding walls. Therefore, it shows darker, because less infrared energy is emitted. Let's take a look at another example of what we see in the visible versus the infrared. The cups are filled with cold and hot water respectively. Note that the color and graphics on the cups makes no difference to the infrared camera, as it senses the heat being radiated from the surface of each cup. The higher the surface temperature, the more heat radiation is being emitted. You can also see the cup's heat signature reflected off the table as well. In addition to temperature, there is another attribute that determines how much infrared energy an object can emit, and we call that attribute emissivity. Let's take a look at this steel can. We have filled it with hot water. There are three different surfaces here: steel, black plastic, electrical tape, and a paper label. All three of these materials are at the same temperature. Let's take a look with the infrared camera. As you can see, there is a huge difference in the apparent temperatures of the tape and the steel. That difference is due to the low emissivity of the steel versus the high emissivity of the tape. In other words, the tape can emit infrared energy much more efficiently than the steel when both are at the same temperature. This can cause interpretation problems as well as measurement problems if you're not aware of emissivity's effects on an image. If we didn't have the tape on the can, you might think the can is about room temperature. Emissivity is an important parameter to enter into your infrared camera if you want to make temperature or temperature difference measurements. So how exactly do we define emissivity? Emissivity is a property that relates how well a material radiates infrared energy compared to a perfect material at the same temperature. Emissivity values vary between 0 and 1.0. A perfect material or blackbody has an emissivity of 1.0. A perfect reflector or mirror has an emissivity of 0. Materials with high emissivities are easier to interpret and measure. Materials with lower emissivities reflect the surroundings and offer unreliable diagnosis. Luckily, many common materials have rather high emissivities. An object's color does not affect its emissivity. Emissivity is more tied into the type of material an object is made from. Consider this cup filled with hot water. We have placed plastic tape of varied colors on the cup. Switching over to the infrared image, we can see that all the different tape sections look the same. Hence, the different colors of tape have the same emissivity. Let's learn a little bit more about emissivity. Here we have a flat aluminum plate, one side anodized black and the other side left shiny. We are heating the plate on a portable electric range. We have a thermocouple attached to the left side of the plate. You can see that the thermocouple reading is 231 degrees Fahrenheit. Yet if we look at this IR image of the shiny plate, the reading says 82 degrees Fahrenheit. The anodized section of the plate reads 230 degrees Fahrenheit with the infrared camera. If we were only looking at the shiny plate, we would have a totally incorrect conclusion about the true temperature. The reason: shiny metals have low emissivities and do not emit infrared radiation well. So there you have it. We have learned that emissivity is just an attribute that tells us how efficiently a material emits infrared energy. Since an infrared camera depends on infrared energy to produce an image, high emissivity materials are easier to see and measure. I'm Gary Orlov, and this has been Emissivity Explained in plain English.